Hello everyone. In this session, I am going to explain about another system software tool, that is Macroprocessor. You know that already in C programming language you have used macros. Okay, these macros are nothing but a set of instructions. Macros are generally contains some set of instructions, and these instructions are going to be substituted wherever you are going to call. Okay, and generally if you are in case when you are writing a program, if you want to use those instructions repetitively, then what you can do is that you can make them as a group of instructions, and then that can be named as a macro. You just invoke the macro, and macro is going to replace all those statements within that definition are going to be substituted. Okay, so now here generally these macros, uh, it is for a convenience of the programmer. It depends when to write the macros and all. It goes with the as per the convenience of the programmer. Okay, so generally what it is, a macro is a group of instructions. Macro processor, what it does, it is a system software tool which is going to replace each your macro into a macro definition into a macro substitutions, or you can call it as an expansion. So your macro processor is going to expand all the instructions which are there under the macro. Okay, you can see here a definition is given. A macro processor replaces each macro instruction with a corresponding group of source language statement. It means that whenever you are going to invoke the macro, it's going to expand that macro. Okay, so here whenever you are going to call the macro, your macro processor will not try to analyze that. It is simply it's going to substitute. It will not find out the meaning of that, means in what is the meaning of and all. It is not going to check. It only substitutes. The macro processor is going to simply expand the macros. It means that it's going to replace all those. The macro definition is going to be replaced by all the statements which are under that macro. Okay, so now we'll see one by one how exactly it is, how we can implement these macros. See, generally if you want to define a macro, you will be using two assembler directives, that is macro and emend. Macro is, it's the, you have to give a beginning of an macro definition, and emend you have to, whenever you want to end the macro, then you have to give it as emend. See how it is given in the example. You can see there, the you can begin with a macro by macro. You can name it as name, whatever name you want you can give, and here you have to give the parameters. As we are going to pass the some arguments in C programming whenever we write a function, similarly here also you can pass um, a parameters to the macro. Sorry, each macro is going to be preceded by an ampersand. It means that you have to give an ampersand followed by a name of the parameter. Then in between macro and emend, whatever the statements you write, those are all called as the body of that macro, and these are the, this body of a macro is going to be replaced whenever you are going to call. Okay, you can see here some examples. Assume that you have written a macro m1. Okay, and the name you can observe here, name the macro is an assembler directive which is going to define a m1, and it receives two parameters, that is d1 and d2, which are preceded by an ampersand. Just see here, it is written it as sta ampersand d1 stb, some code is written. It means that in between macro and emend, two statements are written. Okay, that is sta d1 ampersand d1 and stb ampersand d2. Now just see there, uh, this in between macro and emend, we call it as a macro definition. Whenever you want to invoke that macro, you can just see there here, we have written m1 data 1 data 2. It means that whenever your assembler recognizes that there is an m1 which is already called as, which is already defined as an macro, immediately the macro processor comes into an active comes into here. Then it, what it does, it invokes that whatever the macro you have defined, and it is going to substitute the two instructions, that is sta d1 and sta d2, whatever is there, that is going to be replaced here. How it expands, that we'll see later, but just understand here there is a definition is given, and after that we have called with the two times m1 data 1 data 2. Data 1 is going to be mapped with d1 and data 2 is going to be mapped with d2. In the second call, data 4 is going to be mapped with d1 and data 3 is going to be mapped with d2. Okay, consider this code here. See, this example already we have seen in the our two functions. We had already written a two subroutines, that is read buff and write buff. The same definition is going to be replaced here. Instead of subroutine, it is replaced with macro. Now try to understand this code, whatever it is given here. I will explain wherever it is highlighted. The other part you can easily understand. The first, on the line number 10, you can see there is a macro is defined, and the macro here, it is the name of the macro is given as rdbuff, and it is going to receive three parameters, that is and indiv and buff adder and rec lth. Okay, now come to the line number 55. When you are defining a macro, you have to take some precautions, that is you should not use the labels in the macro. That's what it is done here. You can just see here in the program, you just recall the program what you have written in the subroutine part. There you had written something called r loop td and literally x, something like that. It means that there was an label was there in the label column, but here macro should not contain any labels. So that's what here you see the line number 55, it is written as juq asterisk minus 3. So what the asterisk here represent means the current location subtract with minus 3. It means that go back to the previous instruction. Okay, similarly you can see that juq plus 11, it means that you are going to the means here there is a forward reference is there. You might have seen there is a something called exit was there in the previous subroutine, but here that you cannot write the labels. That's what we are doing, we are going ahead, means you are adding plus 11. Okay, similarly on the line number 85 you can see that jlt star minus 19, it means that you are going back to the line number 50. Okay, so this is what change it is done. Now see here the line number, we have begun our macro with the line number 10 and then we are ending with the line number 95. In between whatever you have written, these are the group of instructions for an macro or debuff. Similarly you can write it for an wr buff also. Now just see here in this case we have defined our macro. Now how to invoke that? Okay, a macro invocation, normally what it does is that you will be giving a name of a macro, whatever the name you are given. In this case it is the name of the macro is it is there here as rdbuff. Okay, then now come over here, see this is a syntax. You have to give here macro name and then whatever the arguments you want to pass. Please understand here, in the macro definition we call them as a parameters, and in the macro invocation we call them as an arguments. Okay, so here macro name and then you will be passing whatever the arguments. Here another important point you can understand here is that there is a small difference is there between a macro and procedures, even though they are performing a similar task. What the macro does is that macro is going to be expanded wherever you call. Whenever you call, each time it is going to be expanded. It means that the whole code is going to be substituted there. But in case of procedure, it's not going to expand. Your control, your the access control goes to that particular subroutine it executes there and then come back to the your calling function. It means that macro substitutes, whereas procedure goes there and then come back again to the calling function. Okay, now when to use and all, it is again, it is based on your programmer viewpoint. The programmer can decide when he can use a macro and when he can use a procedure call. There is no certain rule or a standard rule for a developer when to use macro and when to use procedure. It all depends on the programmer viewpoint and which type of your target machine is there. Okay, just here this is an just example which is given when already this is a very standard example which you have come across in when you want to swap the two variables. See here, there is a some exchange function is written here. In this case there is no change in the before and after. It's not going to change because we are using this call by value. But when it comes here, the pass by reference, you can see there in the exchange we are passing an address. So here you know that this is a very standard C program. Here we can swap the two numbers. Okay, now the same thing you can write it as an in the assembly code. I mean, there we have written a C program. The similar one is written here, it is with an assembly code. You can just concentrate how it can be written. Okay, this is a subroutine, it's not a macro, it's a subroutine which is written. Now the same thing when it comes to your macro. Okay, what you can do is that you can define the macro. This is just an example, we'll come back to this later. But before that, you just understand that in the each macro statement is going to be expanded whenever you call. The body of the statement are going to be expanded. As I told that in the definition of macro it is called as parameter, and in the invocation it is called as an arguments. And another thing you understand here, if you are providing any comment lines in the macro body, they are not going to be expanded. Comments are not going to be expanded. Okay, they are going to be deleted, right? And when whatever the macro, whenever you call a macro and that particular line is going to be considered as an comment line, and then after that it is going to be expanded. That I will show you later. Okay, now then the whatever the macro parameters are there, those are also called as the positional parameters. Okay. Just consider here, here on the line number 190 we are calling a rd buff. What is this rd buff? Rd buff is defined as a macro. See, and then we are passing the three arguments, f1, buffer, and then length. These three arguments are going to be mapped to the corresponding parameters in the macro definitions. Okay, similarly you can see on the line number 210 and 220 wr buff is called twice. Another important thing you understand here, why we are not defining or why we are not using any I will show here. See here, in this case this is a definition of readbuff. You can see there are no labels. What happens if you are calling, if you are using a labels here, the macro is going to substitute the entire code or all the group of instructions in between macro and amend. If you are calling the macro repetitively or if you call the macro many times, the time if label is there here, the same label is going to be reproduced everywhere. Then it is an, the symbol table recognize that it is a duplicate of symbols. There is a duplication in the symbols. That's what you have to avoid, labels in the macro definition. Okay, now you can just see here rd buff is called, what is the here it is f1, buffer, and then length. And now how it is going to be expanded, you can just see here. See, when the line number 190 you are calling the rd buff, immediately the when you once you call, the macro processor is going to replace the complete body of the macro here. That's what the line numbers are given it as 190 abc, means all the entire code is here. Now see that the line number 190 is marked with a dot. It means that that particular line is considered as a comment here. It means that the macro invocation line is converted into a comment line, and then the whole body is replaced here. Okay, so now here it is tdf1. You can just check it out here. The td earlier it was what, ampersand in device, but now here it is instead of ampersand in device, on the line number 190e you can observe there. Here you just see what definitions you are written. See here the line number 50, what it is given, td it's a equal x and in dev. Now in dev parameter is what, f1. So that's what here it is given it as when it's going to be expanded. So that time in dv is substituted with f1. Okay, now the other, in the similarly you can just check it with the other things, and the code is expanded as usual. Okay, and whenever it calls the wr buff, so that time again the wr buff is code, that code is going to be expanded. Okay, so this is what an expansion. Here two times it is called, one here it is on the line number 210 it is called, it is expanded. Similarly on the line number 220 again it is called, again it is expanded. This is what how the expansion does. Now uh, as I told that you should not use the labels in the macro definition, because if the same, if you are calling the macro many times, there is a possibility of getting a duplicate symbols. So to avoid that, what we have done, we have used the directly memory locations. See for example in this case JUQ star plus L1 means you are moving ahead. Whenever you give a minus you are moving, means you are going back for the previous this thing, memory locations. So this is what how you can eliminate the your labels in the macro definitions. Okay, so this is again you need two pass here to process this entire macro processor. In the first pass you are going to process all the macro definitions, and in the second pass you are going to expand all the invocation statements. Okay, sometimes in case if the user, if the developer wish that they can create a macro processor in only one pass also. Okay, so that is anyhow we'll just go with how it is going to be expanded. Another case here you can see that you can define a macro within a macro, and that is allowed. Here you can see that macro s and macro r, we are going to define a macro s which contains the two macros, and that is possible. And similarly here it is with a macro x. Now one thing you understand here, what exactly it's going to means, how exactly your macro processor is going to work. Okay, sorry. See now the whenever you want to process this a macro processor, a one pass macro processor that alternate between macro definition and macro processor, but in a recursively we will be using a two pass macro processor. And whenever you are using a two pass macro processor, it's going to use some internal data structures. Okay, every in the assembler also we have seen that it is going to use some data structures. Similarly here also the macro processor is going to use a data structure, and this is explained for an one pass macro processor. Just see here, the macro processor is going to use three different data structures. First one is definition table. It means that whenever you start defining a macro with a assembler directive called as macro, and then automatically your macro processor is going to create a one definition for that. It means that it is in the definition table, it's going to write all the instructions along with the prototype, whatever the macro prototype is there and the macro body is there, that everything is going to be stored in this. Okay, and the comment lines are going to be omitted, because the comment lines are just for the user references. That's what, it is not it is not loaded into the definition table. It will not be stored in the definition table. Okay, now Another thing you understand here, whatever the parameters you are providing on the prototype, on the macro prototype, whatever the parameters you are providing, those are considered as the positional notations. Like if the first argument is there, that is called as question mark 1, question 1, question 2, like that means you are all those are treated as a positional parameters. Now see, this definition table is going to contain the macro prototype and the body of the macro, right? But there is an another data structure is there that will maintain the list of all the macros which you are going to define. Okay, in the early just we have seen that we have defined two macros, that is rdbuff and wrbuff. Okay, rdbuff is the name of the macro, and then you must know what is the starting and ending address, because once it is stored in the definition table, you must know where, what is the starting line and what is the end line. So that's what the name tab does is that it's going to store all the macro names along with the pointers to the beginning and end to the definition table. In the definition table you are going to store the entire macro, and in the definition table what is the beginning pointer and the end point, that is the beginning address and the end address, that is going to be there in the name tab. And whenever you are calling the macro, you will be passing an arguments. So each time when you call, your arguments may not be same in all the times, but you must know when you call what are your arguments. So that's what there is an another data structure is maintained, that is arg tab. For example, in the previous case we just called rd buff f1 buffer some rec length we have called. It means that these are the three arguments for that particular call, isn't it? So this argument table will provide you, okay, whenever you are calling a particular whenever you are invoking that particular macro, it will just gives you the what are all the arguments you are passing there. Okay, so argument, you can see there here the argument table, it stores the arguments of macro invocation according to their positions in the argument list. Okay, just see here, this is an example. Now we can see the first call, that is rd buff f1 buffer length. When you call the rd buff, first it goes to the name, your name table. Name table in the rd buff is there, correct, and it has got a beginning pointer and the end pointer. Based on that, your entire code macro statements are there in the definition table. You can see there in the definition table on the first line rdbuff and indv buff and rec length is there. See, you have invoked with the arguments, those arguments are there in the arg table. Okay, now f1 buffer length, f1 is going to be mapped with indv, buffer is going to be mapped with buff address, and length is going to be mapped with rec length. But please understand here, these are, whenever it expands or whenever it substitutes, it is not going to substitute with I and DEV. It is, it means it in your definition table, these in DV buffer are not treated as in DV. They are treated as a positional parameter. So that's what it is given it as. Say this is a position number 1, in DV is a position number 1, buff adder is a position number 2, and REC length is a position number 3. You can see in the code X, whenever it is storing there, you can see the line up TD X, it is showed it as question mark 1. It indicates that you are referring to the positional parameter 1. And you can see on the stch instruction where it is question 2, it means that you are referring to the second parameter. Similarly on the stx question 3, it is means it is you are referring to the third positional third parameter. This is what how your definition table is going to store your parameters. Okay, so now just understand here, whenever you are going to, whenever you define a macro, and when you invoke, how it's going to be expanded with the help of these three data structures, that is definition table, name table, and argument table. And the algorithm is provided for that. It is you will be whenever you are going to process the entire macros. So initially what you do is that you need to define the macro, and then you need to expand the macro, so that you can just refer in the textbook. Okay, I have just covered here what is a macro. Macro is a group of instructions, and the one who process this called as a macro processor. We use a macro, we are going to use a two assembler directives, that is macro and amend. Okay, and macro and amend is going to be will it it helps you to define the macros. Okay, and whenever you are going to expand this, you have to invoke like this. Okay, and all the whenever you are writing a macros, please avoid giving the labels, and when you invoke, then the entire code is going to be substituted. Okay, so this is about a macro processor. I hope you are very clear with this. Okay, take care, stay safe.